Good evening.
Hello.
Can everyone see the screen?
Yes.
Okay, so last class we talked about repeat decision. So if there is some action you want to do it repeatedly, we can use the while loop, where the decision will be made multiple times. So each time it will go through the yes no question. The answer is yes. It will keep doing the action until the answer to the yes no question is no. Then it will move on to the next instruction. Now compare the repeat decision with the simple decision. The if statement, your yes no question, or your question will get answer only once. So either you will do the instruction or you will move on. Right, so this is the difference between the while loop and then the if statement. Now, if you just look at the chart, you can also tell the difference, right? So the yes no question in the while loop, you see like there's like 4 lines going in and out from it, and where the simple decision, the if statement, the yes no question, there are only 3 lines going in and out to it. And the last example we did last class, we asked the user to input a an even number, I believe, and then we give the user 3 attempts. Right, so we will keep track of how many times the user tried or try and failed, and if it's C 3 times, then the program will end. So the while loop allows us to also repeat an action several times. Okay, so now let's look at this example. So how can we make the C++ say hello 10 times? So what do we need here to keep track of how many times we say hello? Now I see people mention for loop, but we haven't go through the for loop yet. So try to avoid the for loop. How can we do it with the while loop?
Professor.
Yes.
We need a while, and then we need a counter. Could be let's say while variable name is less or equal to 10. We do, let's say we see out hello X amount of times.
Okay, so so first we need to have a counter, right? So what do we want to set the counter equals to?
10 or less.
So we want to set counter equals to 10, but we need to initialize the counter. Now I see people have 0, 10, and 1. It's really up to you how you want to set up the counter, but you need to just make sure you will go through it 10 times. So we will just start with 0. Okay, so I will start the counter with 0, which it will tell you how many hello you currently have. Right, so we initialize to 0 since we don't have any hello yet. Now we need to go through the while loop. So we need to have a yes no question to determine whether we want to do the action or not. So what should the question be? So we need to make sure C is less than 10. Right, so we will ask, is C less than 10? Now I see people have less than 10 and less than equals to 10. So it really depends what you store your what you initialize your counter with. So if you initialize your counter with 0, where should we start? When your counter is 10, do you want to go into the loop again? No, right? So you don't need to have the equal sign, because once you see it's equals to 10, you don't want it to print another hello, right? Since our counter here, we set it as number of hello you currently have. But if you store your counter with 1, so let's say you will have 1 and then say, oh, you will print the hello the first time, the second time. Then if you start with 1, then you want to end at 10. So when your counter equals to 10, you still need to say hello, because that's your, when c equals to 10, that's your 10th hello. Right, so it depends on what you initialize your counter with. So since we start with 0, then our question will be, is c less than 10? So if c not yet 10, we will print hello. So if the answer is yes, we will let C++ say hello, which we will just see out. Hello. Now, what do we need to do after we print the hello? Are we going back to the yes or no question? Well, I see people have returned 0. If we return 0 here, what will happen? It will just end the program here. So we need to increase the counter. Right, we will set c equals to c plus 1, and then we will go back to the question. So this will be the loop part. And once the answer is no, our program will be done. Right, so you can return 0 there. So to write the code, so first we need to initialize a counter. So we set it equals to 0. And we will set up the while loop. And the question will be, is c less than 10? If so, it will print out hello. Now, after you do the hello, you need to increase the counter. Otherwise, your counter never changed, then it will just keep printing hello, and it won't stop. Right, so once we finish the while loop, we can stop there. So we just return 0, standard ending. Now, I forgot that I mentioned this in this class. So before, when we want to print a new line, we will always use the ENDL, right? The end line. Now, a shortcut for it, or like a shorter way to do it, is inside the quotation. You can also tell the C++ to go to a new line by doing the /n. So this will do the new line, same as the. So this is the same as doing hello and then the end line. So instead of having this end line part, you can just have the /n.
Professor,
Yes?
is that only with scripts, with strings?
Yes.
So
And
that
you need to
wouldn't,
put it into the quotation.
okay. So it wouldn't work with any other type of,
Yes.
okay, thank you.
So when you have, like, let's say you are like writing a paragraph or something, and you putting them into the quotation, and you just want to go see a new line. So instead of like finish the quotation, write an line, and then restart the sentence, you can just have it in the same quotation. So that's just a short way to do it when you have like a long string of code. It's just less to type. Okay, so here, since I have the double slash here, so that means this line is a common, like it's a where it's a common where the C++ don't really read it. It's for us to read it. So C++ will ignore this line. Okay, we will compile it. Then one day you will see it will print hello 10 times, right? So the /n serves the same as new line. Okay, so from here, you see that we can use a while loop to do a repeat action. Now, the difference is you need to have a counter, right? So you need to set up a counter, then your yes, no question will base on your counter. So pretty much it's asking, is your counter valid? Is your counter good? If so, you will go in and then do whatever the action you want to repeat, and then make sure you change the counter. And then you will go back, test the counter again, and then repeat the action until your counter is invalid. Then you will stop. Right, so here is the chart. So you will set up the counter, you will test it, and you will do whatever the action, and then you will change the counter and then go back to the question. Now, once the counter is bad, you will move on to next instruction. Now with this, how can we print cubes of 1, 2, 3 up to 10? So here, 1 cube will give you 1, 2 cube will give you 8, 3 cube will give you 27, and up to 10 cube will be 1,000. Well, so we know this is a repeat action, right? So you keep printing the qubit. So we know we need to set up the counter. So what do we want to initialize the counter with? 1. Right, so 1 is something natural to do, right? Because we start printing the cube for 1. So we need to print the cube from 1 up to 10. So our question will be, is C less than or equals to 10? Because when C is equals to 10, when the counter equals to 10, you still need to print the qubit. Right? So when it equals to 10, you still need to let it go into the loop. Now, when the answer is yes, you will print the qubit, which we will see out C times C times C. Now I will just put a space after it instead of putting it as like a 10 line. So I'll just put it in the same line. Now, after we print the qubit, what do we need to do? Okay, so I see people have the C++. So C++ is just another way. It's just another way to say C equals to C plus 1. So the plus serve the same as adding the 1 to it. Okay, and then we will go up. And then until the answer is no, we will, normally we end the program, but since we print the 10 qubit in the same line, we need to end, after you print all the 10 number, you need to end the line. So we will see out, end line. And then we will finish the program. So I have return 0 here.
Professor, another question. The C++, is that only with the integer C, or if you name any integer, for example,
It
num?
it only makes sense when you see it's an integer value.
I mean, like if I did a different variable name, would it work as well? Like num1 would work.
Oh, yes.
Num1 plus.
Yes. You can have this. Okay, so it's pretty much your variable with the plus at the end.
And it's
So
only plus for +1, right? There's no other
Yes.
shortcut for additioning, adding.
Okay, so there are different notation for shortcuts, which I was planning to probably show you next class, but since you asked, you can use, if you are keep adding like the same number, right? Instead of saying C equals to C plus 1, you can also have C add equals to 1. Now, when you change the 1 to any number, it will means like C plus whatever that number is. So C plus equals to 1, that means you will set C equals to C plus 1. Now it will work the same. You can have minus equals to, you can have multiplication, you can have times equals to, and you can have even so that's how you can use those notation.
So then so you would just put that instead, right? So you just put C plus equals 1, and that would be your counter thing?
Yeah, so I mean, they all do the same thing. They all set C equals to C plus 1.
Okay.
So this is just some shortcut for it. But plus only for increment 1. Now similar, then you can have minus for minus 1. Now there's only shortcut like plus minus for the for increment 1 and decrement 1.
So the plus equals is more versatile.
Yeah, so you can use it for any number.
Okay. Thank you.
Okay, now just be one thing I want to point out. Just be aware when we print the cube, this is not valid in C++. C++ don't read this caret sign. I know in a lot of the calculator or online calculator, we use this notation to represent power, to compute power, right? So normally when we do 3q, we will just expect that you have the number and then raise to the 3rd power. But C++ don't read it. So you need to manually do C times C times C. So if you do this, when you compile it, you will get an error message saying that C++ don't know what it means. Okay, so this will be wrong in C++. So just be aware of that. And let's test it. In our program, so we have int C, we say C equals to 1, while C is less than or equals to 10, we will see out C times C times C. And then we will separate them with just a space. And we will, after we go through the loop, we will end the line. And I forgot to increase the counter. So we have C++. Okay, so that's our code. And we will save it. There's a typo. I miss L here, so I have end line. So you will see it prints the 10 qubit from 1 to 1,000. Okay, I see people asking, well, the modulo equals to 1 works. It doesn't make any sense if you do a modulo equals to 1, because when you multiply by a number, no matter how many times you do it, you still get the same result. Right, and when you're trying to get a remainder when divided by 1, you will always get 0. Right, because the modulo give you the remainder. Right, so if you have a number modulo 5, that means you want to find what's the remainder wherever your number divided by 5. So no matter how many times you find the remainder, it's the same thing. So for modulo, we don't do that. Now, if you want to check, is there like a syntax work, you can always put it into your program, then compile and then see where it works. Now, is there any way we can print this 10 qubit backward? So instead of from 1 up to 1,000, can we do it backward? Right. So let's say I want to print it from 1,000 down to 1. Right. So you still have the 10 qubit, but you will print it backward. Okay. So what should we set the counter equals to? What's 1,000? 1,000 is 10 cube, right? So for the counter, we don't want to set it to 1,000, but we want to set it to 10, right? Because we get 1,000 from the qubit, right? Because if you do 1,000, then you do a minus minus, then the next number you have is 999. Okay, so let me just copy the code here and then just modify it from our previous example. Okay, so this is our code to print the qubit from 1 to 10. Now we want to going from 10 down to 1. So I see people say we can initialize the counter with 0. Now what should our question become? When C is what? Okay, can I say less than or equal to 1?
No, it should be equal.
So while C equals to 1?
Well,
it has to be greater than or equal.
Greater or equals to 1, right? So since we will start at 10, then it will keep going down. And once it hits 1, it will be the last one you want to check. So you want to check while C is greater or equals to 1. Now the CI, you do the same thing. You will print the Q. Now when we change the counter, since we want to decrease, we want to go from 10 down to 1, so you will do C minus minus. And everything else is the same. So if I compile it, you see we have it backward. Any questions here?
Professor, if I want to increment or decrement not 1, like 2, 3, 4, then how would I do that?
If you look at here, you can just set C equals to C plus whatever. So like the old way, how we did it last class. So the C plus plus C minus is just like a shortcut when you just want to increment or decrement one. For other number, you can just use C equals to C plus whatever the number how you want to change it. Or there is a shortcut, you can have C add equals to 1, which is the same as C equal to C plus whatever.
So those three are the same, right?
Those three are the same.
So when you're going, so C minus minus is for backwards, right?
C minus minus when you're trying to decrement the number, which means you set C equals to C minus 1. Right, so this C minus 1 will decrease C by 1. So you will start at 10, print the 10 cube, and then it will decrease it by 1. So you have 9, and then you will print 9 cube, and then 8 cube, and then 7 cube, and so on. Are we all good here? Okay. Now if we look at the next example. So we want to ask user for a number with at most 3 digits. Now, if the user give us more digits, like more than 3 digits, we will chop off the extra digit, which means we want to keep only the first 3 digits. So you will chop off wherever the extra one from the right. Okay, so this question involves like the number and the digits. So what operation will help us to deal with digits? Like any operation that will help us to get the digit. And I see people say divide. And what number do we normally divide to get a digit? Which integer, to be exact? If we divide a number by 2, would that give us a digit? Okay, I see people have 10. Right, so let's check that. So if we let n, again, we are always talking about integer here. If we let n equals to 1, 2, 3, 4, 5, and then I have n over 10. What does n over 10 give you? One, 2, 3, 4. So what does it do? It cut off the last digit. So divided by 10 means drop last digit. Now I see people say you can also do modulo. If you do n modulo 10, what are you getting?
The remainder.
The remainder. So what do we get exactly here? What's our
4.
Okay, so let's say we take n to be our original number.
5, 5.
This is our n, right? So the modulo 10, it gives us a remainder, but when we do mod 10, it also means the last digit. So the modulo 10 will find the last digit. So you know with the division and modulo, one will get rid of the last digit and one will give you the last digit. So this will be like the two important operation we will use when we're dealing with question related to numbers and digits. Right. So if you look at this example here, questions?
Yeah, is there a way to print to cut off just the first? So print the last, or did you do modulo by the tens place? So for this one, it would be like modulo 1,000.
To get rid of the first digit.
Yeah, so it would be like modulo 1,000, right?
Okay. So the points you can't really do that, because if you do modulo 1,000, if you know how many digits you have, then fine. Like if like here you have a 5-digit number. If you want to get the last 4 digit, you can have mod 10,000. That will give you last 4 digit. Right. So if this question will chop off the extra digit from the left, which you only want to keep the last 3 digit, then the question will be much easier. You just do mod 1,000. But the problem here asks you to keep the first 3 digit, which means you will chop off the digit from the right. So you can't really use the modulus, because modulus like 10 to a power only give you the last whatever amount digit you want to have. But when you want to get the first few digit, you kind of need to do some work to get it. Does that make sense?
Yeah.
And also another problem is, since here we ask the user for a number, so you don't know what number the user will give you. The user might just give you 2-digit number, then you don't need to do anything. But because we will ask the user to enter a number with at most 3 digits. So if the user gave us a 1-digit, 2-digit, 3-digit number, then it's fine, right? You don't need to do anything. But if user give us more than 3 digits, then we need to do something, get rid of the extra digit, and then reprint the number. And here, when we ask the user for a number, we will assume we ask for like we will assume the user will give a positive integer. Questions?
No, I was gonna say you can put it so that integer, as long as it's less than 990, less than or equal to 999.
Okay, so if the user input is less than 999, you don't need to do anything, right? But the question here asks us to take care if the user gives more than 3 digits. So how do we cut off the extra digit? Right. So for example, if we let n to be 1, 2, 3, 4, 5, well, it's definitely more than 3 digits. So we need to chop off the last digit, like chop off whatever the extra digit. So let's say we get rid of the last digit. Then our n becomes 1, 2, 3, 4. Is it good? Or we still need to cut off more digits?
Cut off more.
Cut off more since we have more than 3. So we will cut off 4. And then we will have 1, 2, 3. Now is it good?
Yeah.
So once you left with only 3 digits, you don't need to do anything because it's less than 999. Now I see people say, can we do modulo 100? If you do modulo 100, that will give you the last 2 digits. Which, if you just check the n, it will give you 45. Now, if you want to divide 100, yes, you will get 123. But now, if you kind of hard code that in, if you do divide 100, then what if the user gave an input that's 1, 2, 3, 4, 5, 6, 7? Then you will just divide 100 and you will get 1, 2, 3, 4, 5. Do we see the problem? So you can't really do multiple digits at the same time. So what you need to do is that you will check, is your number too big, right? Is your number more than 3 digits? If your number is more than 3 digits, then you will get rid of the last digit. And then you will check it again. Is it still too big? So you will keep get rid of the last digit until your number is good. So what's our counter here? The integer. Wherever the user input. Now we need to check is n too big. So we need to check is n more than 3 digits. So it's n greater than 999. If the answer is yes, you need to get rid of the last digit. You can do divide equals 10. This is the same as you will say n as n over 10. They are the same thing. Now, after you divide the 10, you can just go back to check is it still too big. So this will do the action, also serve as the counter. So you will go back. So you keep doing it until the answer is no. No means your number get down to at most 3 digits. And then we can finish there, or we can print the C out. Print the number out. Okay, so this is our plan. Okay, and we will try to code it. Okay, so first we need to initialize, declare a variable n. We can initialize it, and we will ask user for it. So before we ask the user, we need to, in order to get input from the user, we need to ask for it. So we need to give a prompt. So we'll ask them to enter an integer with at most 3 digits. And then we will store the variable. And then we will check if the user listen to the instruction. Right, so we'll check is n greater than 999. If so, that means user did not listen to the instruction. That means you need to do something. Then you will get rid of wherever the actual digit user's input. And then after you've done all that, take here the actual digit, or if the user just gave a number that's at most 3 digits, then you will skip the whole while statement, the while loop, since it won't get into the loop. Then we will print out your number is, and then we will print the C out. We will print the number out, and then we will end the line. Any question here with the code?
So you just pick any random number, you say 999, right?
Okay, so the reason we have 999 here is 999 is the largest 3-digit number. Anything greater than 999 will have more than 3 digits. And that means you need to get rid of the last few digits.
Oh, okay, I see.
Right, if you if you really want, you can say if n is greater or equals to 1,000. If that may get better, right? Because 1,000 is the first integer that's more than 3 digits. They are the same thing.
Professor,
Yes.
is there a way to basically identify by how many digits it's over and cut it by that amount in one go?
Okay, not really with the integer type, or with what we learn now. The answer is no. But if you're allowed to use different libraries, like when you learn more about C++, the answer will be yes. There are other like shortcuts, method, function you can use.
Okay, thank you.
So since this is an introduction class, my answer will be no. Okay, so that's what we need, like a while loop to keep check. Are we there yet? Okay, so this is our code. And we will compile it and run it. So it asks us to enter an integer with at most 3 digit. So let's say we read the instructions. So we just give a 2-digit number. It's fine. It will just return your number back. Same thing if you give like a 3-digit number like 999, it will also just print you 999. But if you give like more than 3 digits, like 1, 2, 3, 4, 5, it will just print you the first 3 digits, 1, 2, 3. So we know it works. Questions here? Okay. The next example, let's do one more.
Well, Professor, I can't see the question. Thank you.
Okay, so you will ask the user for a number, and then we will assume it's positive integer. And we want to print the number backward. So for example, if the user gift 1, 2, 3, 4, 5, you will expect it to print 5, 4, 3, 2, 1 on the screen. Okay, I see people asking, is there ways to print strings and variable together? In Python, you can do F. Okay, so there are some shortcuts if you want to print. Like integer variable inside the string data, like there are commands you can do it, and you can. So if you want to know, you can always search it up. There are a lot of shortcuts. So yes. So the answer is yes. The syntax might be different, but there is similar things in C++ like that. Okay, so let's go back to this question. How do we print a number backward? Right, so there are like different way we can do it, like an easier way and then like a harder way. Since we only want to print the number out. You don't need to have an integer that's backward of the of our input, which means you don't need to have an integer that's 5, 43, 21. You can just print one digit at a time. Right. So for example, here, if a user input 1, 2, 3, 4, 5, you want to print 5 first, and then 4. Let me write this. You'll print 5 first, and then you will print 4, and then you will print 3, and then you will print 2, and then you will print 1. But instead of in each digit in a line, you will just print it right next to each other.
So you could do a counter with a modulo and the modulo going down.
Okay, so so our counter is pretty much just the number. Right, and then we want to keep getting the last digit, right? How do we know when to stop? We will have like the last digit to be 5, and then you will print the 5. And then you will print 4, and then you will print 3 next, and then 2, and you will print the 1. So once you get rid of the last digit, right, your first digit, you will stop there. So our counter, it will just be the number itself. And our question will be, is there more digit? Now, how do we know is there more digit? If you have only one digit, like 5, after you, okay, if you just left with 1, after you print the 1, how do you know you have nothing left?
If it's less than 0?
When it's less than 0, or when it hits 0. So when n, so you can have 1. So while your n is greater than 0, you will keep getting the digit out. Right. So your question will be, is there anything left in your number? Right. So is your number greater than 0? If so, you want to get the last digit out. So you will print the last digit. Now the last digit, you can get it by modulo 10. Now this is the action you are doing. It only gives you the last digit, but you need to change the counter. So after you get the last digit, you need to get rid of it. So you will chop off the last digit. I will just do n equals to n over 10. And then you will go back to the questions. And once you have no more digit left, you will just end there. And since we print one digit at a time, after you print all the digit out, you want to end the line. So we will see out ENDL. And then we will finish there, return 0. So let's check it out. So we'll ask the user for input, enter a number. And then we will store it. Right, that's how we get the number. And then we will check, is there any digit in it? And then is it greater than 0? If so, we will print the last digit. Right, and since it will print it in order, then you will have it print backward. Then we have n equals to n over 10. Okay, so let's say we enter 1, 2, 3, 4, 5. It will print as 5, 4, 3, 2. Any questions here? Are we all good?
Yes.
Okay, so we will end the class here and we will continue next class.
Have a good night, Professor.
Have a good night.